First things first.
The
Happy
closure is
2023, people.
Oh, I guess, yes.
This is the last session of 2022.
Oh, what do you mean? We can do it tomorrow as well.
Well, but we won't. So. Okay, so long story short, we want to do something that's not gonna like take a gigantic amount of time as the type aliases. So we want to implement the Progn, but then we discovered that doing the Progn as a native function is problematic because that involves having an heterogeneous list, which is not possible with our current abstraction. And I don't think it should. I actually don't agree with that approach.
Well, we can make a type any, right?
Yeah, we
Like in
could screw
Scala.
everything over and make JavaScript. That's kind of the solution.
No, that's a Scala, man.
That's Lisp, but also, but.
Yeah, but Lisp is actually intended to be dynamic.
Yeah,
Like
I know. Anyway, so then we discussed about we have another alternative solutions to solve the problem. One of them is to make another node for this sort of thing, but the quickest way is to just change the abstraction node to instead of having an expression here.
Yeah, because the main body is already sort of like that, right? We just evolve a bunch of things and then just, well, there's no like return really.
Well,
There
this
is
is the
actually, right?
return.
The
This is
last
the
one.
return.
No, what I'm
Oh,
saying is like lose on a file. Like the last thing is the one that gets
yeah, the last thing is
evaluated.
the return. The last thing will be the return of this thing.
No, not this thing, dude. What I'm saying is this. Can I open? Let me go to the
Well, when we
functions.
type check, we're gonna have to.
This. For example, look at this file here.
Fun.
I know most of it might be wrong, but like there are many expressions, right?
Wait. You are in which file? Fun.sw?
Functions.
Oh, functions. Okay. Okay, I see what you mean. Okay, go.
So you have many things, right?
You have many things. Yeah.
So when you have, for example, something like car, blah blah, print, blah blah. Blah blah. So when you have this, what is the one that's when you evolve this file? Think about this. When you evolve this file, what is the thing that gets returned from you?
Well, it depends what you mean with evaluating this file. Do you mean using that approach that we discussed in offline about having, if you don't have a main function in the file, the
No,
main function is
I
the
want to
entire
know
scope of the
how.
file?
No. I that's not the problem. Like I understand what he's saying. Like if we should do a main so we can get our only one representation, right?
Yeah.
But ignore that.
Okay.
Like think of just these three expressions you're in a file.
Okay.
Like right now, what happens? Doesn't it go for this and then evolves?
Yes.
This evolves,
Yes.
right?
Yes.
So that is the same thing. We don't need to add a new node on the AST because on the body, like
Oh
it's the
no, I
same as
agree that
Lisp.
we don't need, but we could.
Yeah, but it's redundant, right?
Yes.
Because like it's already implicit, so it's kind of dumb. On an if, we can still add that though, because for example here, you cannot do it here on an if, right? So we would need a program here.
Yeah, if you want to have an if, a program available in the if, then. Oh no, we could do the same. We don't need a program there. We can just make it implicit. Just go to the types, and the
No,
condition. We can
but
just have lists of expressions all over the place.
we can, but dude, it's better just to make a new node because it will be. Well, we can make it like that, but I'm not sure, man, of changing everything just because of adding this.
Well, we're gonna have to change everything regardless, but
Not really.
yeah, really, because if we change
No,
in the abstraction, we're gonna have to change evaluation, type checking, and parsing
of
of
the
that.
abstraction.
If we
Yes.
add a new node, you're gonna have to add another pattern matching
Yes,
for type
just that.
checking, for evaluation, and parsing. So
For
it's
a program.
for
Just
a
that.
program.
You're
Yeah,
not
no.
gonna have to do for a lambda. For abstractions are already lambdas. For an if, a condition,
Oh, you
you
mean
don't have
doing
to
for
do.
all of them?
A let, like all of these, like we
Oh.
don't have to do. We
Oh
don't have
yeah,
to
no,
do
then you're
if we
right.
do just a node.
I was thinking about just doing an E abstraction, dude.
But
You're thinking about doing everywhere. Okay, then you're right.
I think we can even do just a program and then on the abstraction we
Mm-hmm.
parse and insert the program there implicitly.
Wait, can you
So we
repeat the
just
last
do,
part?
like, think about this. What is the if we do a generic program thing, we can just parse the abstraction and say, okay, if it's an abstraction, parse the body and send the body to a program node. So you don't have to change anything.
Oh, you mean the parser would inject a program?
Exactly, because it's implicit, right? Yeah, dude, like it is implicit, right? So you just inject
No, but
it
I don't
and you
see.
don't have to worry.
Oh, but if we're gonna make a new node just for that, just for the program, I would advocate to force the user to type that. I wouldn't I would
Yeah,
prefer having to
okay.
type that instead of
Okay,
having
but
implicit.
I think it is very stupid to make the user type program on a function.
Well, then you need to say okay, so Lisp is stupid then.
You don't have to type a program on a function. It's implicit.
Oh wait, that is the exception, right?
Functions and I think lambdas are also. What else? There was something else. I think ifs are not.
Okay,
Yeah,
so
ifs are certainly not.
okay, then we can do that like that because we can just like inject a program implicitly in the
Because
parsing. That's not a
it
problem.
would be bad segregating the behavior because you have to do twice and change all the AST and the evaluation. That's a lot of trouble.
Oh yeah, that's more stuff. Okay, so let's go to the types.hs.
Let me
Let's
just revert
go
this.
and let's put eProgram. And as far as I can tell, this guy will receive um, a type and a list of expressions.
Let me think. So the type is the return type. We don't need
Yeah,
it.
we don't need that, you say.
Well, the type of the program is the last expression,
Yeah.
so we don't need it.
Okay, so this is kinda like the list, but not
Yes.
quite.
Yes.
Okay, so let's go first to the evaluation. I want to start with that.
Oh, Nathan is here.
Yeah, Nathan is here. Okay, so I guess we just copy paste the list, and let's explain to Nathan what we're doing. We are adding the program, Nathan, and we discovered that we couldn't come up with a way of doing that as a native function. So
No, I don't think that makes sense.
no, no, yeah, but we already said that a bunch of times, and usually Nathan comes with a solution, and then we are just stupid. Um,
So, okay, this does not evolve to a value itself like a V program. It evolves to the
ooh,
last thing,
this evolves
right?
to the last thing. You're right,
So you
but
just ignore the rest, and the last thing is the real
okay,
deal.
so it's gonna be
So,
last.
yes.
Okay, that's
Mm,
okay. That makes sense to me. Okay, so typer.
where
So
is
the
it?
typer, let's go to the list again. I'm so
Active.
fucking glad, by the way, that
Uh,
doing the half of the type alias that didn't destroy the compilation. That's so cool.
yet.
It will, but I don't know.
So, all same type. Uh,
We don't need
no.
that. We don't need that.
Yes, this goes away.
Okay, so then we type
Um,
check the list of stuff. We reduce them. I
mhm.
guess that makes sense. Are we gonna
Okay, one
enforce
thing.
that the
Yeah,
intermediary ones needs to be
yeah,
unit?
yeah. So decision, right?
Yeah,
Let's
so we
go.
actually
I'll,
do
I'll
need the
go here.
all.
So we can force. F sharp doesn't. It just
Lisp
ignores.
doesn't.
Lisp doesn't. I think Okamo also doesn't. It just ignores, right? The other
Yeah,
expressions.
it just ignores. But what should we do about that?
I think.
I don't know. It kind of feels wrong.
I know it's not. Well, uh, actually, I think it's better. Let me think. I don't think. Okay, there is a consequence of you typing something and you think you're causing something, right? I don't know, man. To
Well,
me, it makes
Nathan is
sense.
saying that F sharp throws a warning.
Yeah, it just gives a highlighting saying, like a warning saying, oh yeah, implicit ignoring. Please add a ignore
Well,
clause.
this is a transformer. We can print warnings if we want.
Well, that's a decision, man.
That's a decision. Magetta style, we would ignore it completely.
I'll
So,
just continue doing it.
okay, so, well, if we
If,
decide to not do it, we don't need the all same function because what we would do, we would pass a list without the last element and check if they are all unit, right?
yeah. So it's like a reversed coder.
Yeah. We have a function for that, I guess. It's called init for some reason.
Okay, that's weird.
Yeah, that's a bad name.
Oh,
Uh,
like most
any
of the function names. I
No, not
just needed
really.
to
A
bash.
lot of function names I like the name
Just
here.
needed to bash. Like, they say you like HD in Okamo? That's lovely. I love
Yeah, I
it.
like head, which is better. So. Anyway, so now we need to make. Okay, let's just make a to do here. So to do.
To do what?
Uh, add a warning message to
Okay.
the elements that are not unit type. And then aside from the last one, of course.
Okay.
Okay, so because of that, we can comment this.
I don't want to think about the Haskell operators. I'll just do
Okay, that's
this.
that's that's so exactly what we need.
And
Oh, actually no, we don't need the init here because we actually want to type check the last one as well.
okay, all them together,
Yeah.
and then we do the init here, right? So wait,
Yes, exactly.
what are these cases, man?
These cases are if you
Wait,
have an empty list
wait. What is this list types? Let me read first. I don't recall what is this. So we are basically looping through the list and doing
and type checking and
type
reducing it.
checking and reducing it.
Yeah, because we were doing comparisons with them.
And then if the list is empty, like the program is empty, then
Then we return this thing.
it's just unit, I guess.
If the list is empty, we just return unit. Yeah, that's right. That's actually right. T unit. We don't need that. Okay, if we have something with um, one or one or more elements, right?
Mm-hmm.
Then we are doing a guard, checking if they are all the same. But in this case, we don't need to do that because we're gonna just ignore it. Um,
Okay, and we return the type.
yeah, so we can do like this. Check
Yeah,
this
so
out. So we
we make a
put
type of the list. Okay, because the list
non-empty
is a literal.
list, and then we just do pure last non-empty.
Yeah. Mm-hmm.
I think that's pretty
So
much it.
so that's it, I guess.
I guess.
Yeah, I don't.
I also it seems too easy to be too easy to be true, but I guess. Okay,
Yeah,
now it just
don't
remains to
think
do
there's
parsing,
anything.
I guess.
Oh,
Um,
I'm really starting to think like Nathan, man. Just loading the language. It was way easier on doing the compilation thing. Just load the stack REPL and test it there.
well, I guess we
Yeah,
can
but
do that.
let's go. Let's
No, no,
learn the
but we can
parser
do
one.
that if you want. It's just gonna be
Yeah,
a pain to test it properly, but
parser. Oh, not this. Parser.
so this is an expression. This is gonna live here. Let's go. So this is gonna be a Progn P. So this is gonna be a parser T expression because it's an out-of expression. A Progn P does what exactly? The first thing it does, it
I didn't
checks
even
for a
think. I just
between.
started the between.
That makes sense. Open the delimiter and close the delimiter. We don't even need parentheses.
Oh yeah.
Close the
Let's
delimiter
do.
there. We're probably gonna want to do
Okay.
some lets in here.
Yeah. So let's think here.
So
So it
keyword
should be. Oh, actually,
string
open the
program.
limiter. Yeah, we can do. Okay, we can do like that. I would do it here on this already.
Oh no, the
Like,
open delimiter already have spaces.
wait. So spaces on the end, right? Oh,
It's
because
spaces
I
on
would
the
do.
right.
on the right.
Yeah, which
That's
is
not a
actually
problem
wrong. It
because
shouldn't be space. It should be skip. But anyway,
yeah, but I was thinking of this like
where are you?
oh
Open
here,
the limiter. Oh
and
yeah, that
then we
works. That works.
but then we would
That's cool.
need yeah
That's cool.
you reduce this clutter up
Okay,
there, but then you need
then I think
spaces
we can
again.
reuse. Nah, we don't use spaces anymore. By the way, we will use skip
Okay.
because that will also skip comments.
Oh, I see.
Uh, okay, we can reuse, I guess, the literal list p parser. Yeah, that works.
The
Awesome.
list, the literal list. Oh yeah, it's the same as the list.
Yeah, but this is using this, by the way. You see?
I'm not seeing where you are. Let me follow
In the
you.
same file, line 103. So
Yes.
this is the parser that we use for lists.
Ah, it's the same thing, man.
No, it is not, because this has this.
Yeah, you just change this.
Well, then we're not gonna reuse it. We're gonna rewrite it and copy paste
Yeah,
it,
but
I guess.
dude, this is the same. That's what I'm saying. Like, just copy these, paste
And
there.
this let also.
It's literally Stack Overflow programming. Do this.
Stack Overflow programming.
I'm proud. I'm proud to say that I don't enter Stack Overflow.
I'm proud to. You are proud to say that you don't enter there.
Yes.
Yeah, that's an accomplishment, I guess.
That is. Where is the program, man? I forgot.
54. You are
Oh,
not
here.
programming enough, Nathan says, and I agree.
No, I'm doing SQL. I'm doing SQL every day.
Awesome.
Yeah, it's just that the stuff I do, there is nothing on Stack Overflow because nobody does it. It's just some old boomers doing stuff. So okay.
Wait. No, man. I think we're doing it wrong. You know why?
Why,
Because
Lemus?
uh,
What are we doing wrong, Lemus? Please
here,
tell me.
take a look. So
Hmm.
in our program, the program receives a list, right? What is the list syntax in Silverware? It is this. And then we have
No,
all the
dude.
expressions in here.
No, dude. You're mistaking the literal list with a expression list. Those are two different things.
No, but look at the literal list expression, dude. This is
Because
literally
that is
parsing a list
literal.
of expressions.
Yes. What's the problem?
We can just reuse it. We don't need to copy paste it.
Dude, but then you would do a program with a list? That's stupid.
Wait,
Why would you do this, man?
now I am
Dude,
confused. In Lisp, wouldn't you do this? Program and then parentheses and then stuff?
no,
Oh, in
no,
Lisp
dude.
you don't
It
need
is,
this purple
dude.
parentheses?
It is like this, and then I don't know. It is not like
Oh, okay. So
this.
there
I
isn't
think it's
extra
like this.
parentheses. No, it is
No,
like
there's
this.
not. No,
Oh no. So it is
no.
like
Yes, I'm just making like yes.
okay. So this
This
is
is how it
correct.
is. Yes,
Oh,
this.
okay. So then you are right.
Because
Okay.
like this is a literal. Like that's different.
Okay. We
I
don't need the
literally
from
just
maybe
bashed.
stuff.
You're not programming enough. Why would you use a Stack Overflow if you can order a giant reference book from Microsoft? Man, I will take.
Correct.
Man, I will take a screenshot
Correct.
of my browser when I'm working to you. It is literally just this, like Microsoft. Oh, dude, I literally look here SQL, and then all the references that I have is like SQL transact SQL reference SQL Server, Microsoft Learn, like all the documentation from Microsoft. I
I
just
guess
have
we're done,
this.
by the way.
Yeah, I think so.
I just
I
added
hope
to the
so.
list here.
On the export, did you add as
No,
well?
we don't need to add to the export. We just need to
Oh
add to
yeah.
the expression p.
Okay. So
Okay.
that's it, I
So
think.
save. I am already sharing my screen, so you guys can see the
Oh, we
compilation.
didn't do. Okay, but we didn't add the implicit injection on the abstraction.
Oh yeah, we're gonna have to do that. Oh man, I don't like that because the
Dude,
abstraction and the application are the worst ones. But let's go.
yes, I read this code and I just go, oh, QB.
Let me
Okay.
think a little bit. It's easy, Nathan says. It should be. I just need to remember.
Yes, it should. I don't know where though. Let me see. Prelude last.
So this is
No.
adding the lambda. This is just a parser for the couple the couples of
Many.
names and types.
Uh-huh.
Uh,
Oh, these are the pairs.
yes.
No. Okay, this is ending the stuff,
Yeah,
and
this is
this
the
is
type of
the
notation,
expression.
and this is the body. So the
Yes, I
body
think
is
so.
in here. So then we need to think, where is this being used? This is being used in the first. This is being used in the
Um,
first. So
wait, isn't it just mapping here as a many?
isn't it just mapping? Oh, there, yes.
Okay, and then we just add
Yeah,
the
but then this is a
form, right?
list. Yeah,
The
but then this is a
abstraction.
list here.
Oh, here. Oh, dude, here. Like we do. Okay, let's see. Let's see. So many. I think we need to enforce one at least, right?
Yeah, we need to enforce at least one.
So then this body would be a list.
This body is a list now. But
And
then this is not
then,
going to type check because the E abstraction expects an expression, and now body is a
yes,
list.
yes, that's fine. And then we make a e program. That's it.
And we need to do that as well in the type abstraction. Is that it? I would be, I don't know, man.
Yes, I think so. Okay, let's see on the
Compile.
type. Oh, you're gonna compile straight away, like.
Oh yeah. Oh yeah.
Okay.
Okay, we are half of it is already okay.
Dude, imagine if we started changing,
Oh, it
like adding
worked.
implicits everywhere.
It worked. Okay, now we need a test. Actually, first we need to test if the abstraction is broken. So the first thing that we need to
Yeah,
do,
that's the fun. I think there is one there.
fun. No, we don't
Yeah,
have. Oh, there is a
ABC.
fun here. Okay, there is a
ABC.
fun. There is a fun. Okay, so let's test fun. So stack exec this um, examples fun. Oh man. Okay, it worked. That's cool.
Nice.
Okay, so it seems like. Did I save everything? Let me just double check that. Because
I
I'm
think you
kind
saved
of.
something you shouldn't, but let's go.
Oh yeah, didn't build anything, so I already saved everything.
Alright.
Okay, so now we need to make an example. So let's make an example of a use case of a program. So program.sw. Okay, we need. Man, Magetta loves ABC naming, man.
Yes. What's the problem then? I don't see it. Let's make it interesting. Let's do a list of.
Wow,
Let's
is
do
that gonna
for
work?
all. Let's
I
do
don't know.
for
I
all.
don't remember doing that like that.
For all T. Was it like this? I don't recall
Oh
our
no, yeah, that
syntax.
will work. Okay, we have types for lists.
I don't recall our syntax. Was it
I
like
don't recall
this?
my syntax as well. I don't. I wouldn't even try for now. I think there is
Oh
a
wait, it
semicolon here.
should be like this, I think.
There is a
This
semicolon between
like this.
the. No, there is a
What?
semicolon between the dot and the kind, like
What?
this.
Oh yes. Oh, okay. The syntax is for this. Okay. So
Let me just double check that.
oh, we cannot map with a plus, right? We don't have the operator plus.
Well, we do have the operator plus,
Hmm.
but we don't have. We can't treat it as a function, which is a problem.
Yeah. So
And this is gonna be integer, integer.
yeah, but I wanted to do something with two lines in there.
Oh, print the map and then return the fold or something like that.
Print the map and return the fold. Yes. Okay.
Well, I think
Can
that
we do let inside here? We
of
can,
course.
right? Hmm.
Not
Yes, but
having high, not
okay.
having color brackets is terrifying though. I'm
Yes.
lost already.
No, that's fine. It's right. Print. So the return of this thing is an integer, and then we map the x with a function first, I think, right?
Yeah, we're gonna have to have a function. I don't know which function you're gonna use though.
Um, good question. Should we do another function that is increases?
Well, we can. This is not a problem.
Integer. And then we just do x1. That's it. Oh, yes, sorry.
Yeah. Okay.
Okay, and then inc here. Is that it?
I guess.
That's kind
Oh,
of
this is
weird. We
wrong.
should
No, but
pass
this
with
is
this.
wrong because map returns a list. So this should be like that.
Oh yes, that's true. Okay, and then let's just print a string hello with a happy face.
I will be surprised if this works though.
Oh wait, they're not calling it, right?
We're not. Yeah, we need to call it as well. Yeah.
Okay, let's try.
Okay, I have a question though. I have a question
Mhm.
because my guess is that this will not type check because
The for all is probably wrong. Yeah.
no. I think this will parse. Actually, why we just don't try it?
Oh wait, we need to parse. Wait. This is a for all, right? So we need to send an integer here.
This is a for all. Oh yeah, this is a for all. You need to say that. Okay. Let's see. So, Progn. No declaration
Okay.
found to type check.
What?
No declaration found to type
Can you open
check.
the REPL and let's type there?
Before you say that,
Oh yeah, good.
okay, nothing was found in this file. Oh, I didn't save. That's why.
Okay, but that's a better message.
No, because this. Oh no, you're right. This would be a better message. I'm confused. Why this is not doing stuff? No declaration
Yeah.
found to type check. The file is there, so the file is
Hmm.
created. Cat examples program. Yeah, okay, so things are there, definitely.
Hmm.
Hmm. No declaration. Well, how this is a type error, so let me go to the typer.
Oh wait, didn't we need a special syntax for the T for the type variables? Like
Oh, that's true. No, but that doesn't make any sense then. I
to
remember
give it
that
the
you are
special.
right, that the type variables need the exclamation mark, I guess, to differentiate them from normal variables or stuff.
Hmm.
But it's saying that no declaration found. How is that possible? Let me think.
Dude, our language looks so cute, man.
What looks so cute?
Our language looks so cute
Oh
already.
yeah, yeah, it is. Okay, so no declaration, no declaration.
What?
Okay, the type checker has this. Okay, so the list of declarations that is receiving is empty.
Can you double click? I think it opens the file instead of the Git.
Okay, so it's on the typer though. We can just go there. Yeah, so it's in here. No declaration found to type check. So the thing got empty list, which
Yeah,
doesn't make
so
sense.
that's strange.
So
Dude,
I am confused.
can you open the REPL?
Yes.
Let's try to send each one of those.
Okay, so let me grab the Progn stuff. Progn. The only thing that sucks is that we
Ah,
need to have
yes, the lines,
one-lineable
right?
stuffs. Okay, so this. There's
Hmm.
something wrong with this. Oh, of course there is. Wait, then I am confused. Because it's missing the type here. Then the parser
Okay,
is totally broken, so let's go there.
but wait, wasn't that optional?
No, it can't be optional. I remember having this conversation with Nathan the last time around. It was not optional at all. But why the parser didn't scream, saying, "Oh, uh,
Yeah.
yeah, it's not optional. It's not optional. The part definitely not optional." But then I have questions, which is why the parser didn't say, "Oh, this is wrong."
Let's continue with the other and then we go back to this issue.
Okay. Um. Okay.
I added the
Save.
unit.
Still nothing.
Um,
So
yeah,
okay. So something is definitely wrong. But let's do like that. So this is gonna end as an integer. Okay. So if we ask the type of ink we have there. Okay.
beautiful.
Beautiful, he says. Let's grab this other function here, which is this monstrosity. Um,
Uh-huh.
Unexpected
Unexpected
this.
kind starter.
Okay, so let me go to the typing of that.
It's on the for all, right?
It's on the for all. Okay, so how we are doing that? So we are using type variable generic
Oh, I see. Yeah.
between the for all and the semicolon. The for all
Let
and
me
the
look at your screen.
semicolon.
It's better.
We have two things. So it's gonna
Oh
be
yeah.
that.
Oh wait, there's a dot after the semicolon. Are we doing it right?
No, no, no. There is a dot after the type variable generic, which is true here.
No, no, dude. The semicolon is on the. They're swapped.
No, but it is in the between. So it starts as a for
Oh,
all, and
I
then
see,
things
see, see,
happens in
see.
the middle. So this needs to come after the
Yeah, the
type variable
last.
is already there. So the type variable is here,
Yeah,
and
that's
so
fair.
it's after. That's correct.
Hmm.
Then, oh, there
How
are
do you?
parentheses. Do we have parentheses?
Yes, we do.
I don't think we do.
We do.
Yeah,
Go
I
back
don't
there.
think we do. So
Look.
let's do that. So how does that work?
Oh wait, do we need parentheses on the for all as well?
I guess.
Oh no.
No.
Wait, that includes the list, I guess, right?
I don't think so, because if you pay attention to how the between works,
It
we
is.
stop at the kind.
No, 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 no. But wait, look. It is something and a
Oh,
type P.
type. Yeah, you're right, you're right. Okay, so it's this, but it
We
needs to
gotta
enclose
write the
the...
standard of our language, man.
Yeah, same problem.
Try to parse only a for all for now, like a dumby for all. Remove. By the way, like, is that the type variable being parsed correctly? It's failing on the F though.
Well, instead of doing like this, we can just go to the REPL like that. Are we exporting... No, we are not, but then we can just fix this like that. Okay. So we do that, and then we do parse. Type for all. Do we have type for all available? Oh yeah. Okay, so parse, type for all, this and that, and then I'm guessing that this is how it works. So then you put the exclamation mark and then T, and then
Mm-hmm.
dot, then the kind,
Yeah.
then the kind,
And then a type.
dot, kind, yes. And then the type, so the type, I don't know, integer, yeah,
Yeah.
integer. And I think that should be enough. And it's saying unexpected parentheses. So let's remove those. Unexpected star. How are we parsing kinds, by the way? Oh, we don't use the symbol. We
Oh
type
yes, because of
star.
multiplication. Because of multiplication, man.
No, but we can solve that right now. After I fix the parser, this is
Yeah,
possible.
type star. I prefer typed better.
Oh,
S.
okay. Now I am. No. Let me double check in the types here. Mm-hmm. Oh, I think I know. No.
Um,
Okay, so star is now complaining.
is it a space after the variable, the dot?
I think it is space related, but not that.
Let
Because
me see.
look, after
So
the dot, we are already skipping, well, spaces.
yeah, but there's another space there. Go back there between the semicolon. No, sorry. I think the dot and the star.
The
Go back
dot
there.
and the star.
Go back there.
Yeah, there is
Could
a
you do
space
that?
between the dot and the star, but we are doing that. So that after the dot, we have spaces.
Yeah, skip. Yeah.
And then we have this. Interesting. And then what I think is happening actually is that we don't have spaces between the semicolon and the type. So that's why I removed that. But it's complaining about this. I wonder if the kind parsing is correct. So kind
Try to
star.
parse kind. Yeah.
Oh, this guy is not available. So nuke u.
Import.
Okay.
Yeah.
Okay, so it works.
Try parsing again the other.
The other
The
you say.
for all. Try parsing again the for all.
One sec. I also want to check type variable generic.
Mm-hmm.
Okay.
Yeah. Yeah, so it's
Okay.
with the bang. Lovely syntax.
Oh, it is because we wanted to also be able to have non-capital type variables.
Yes. we could have just gone with a like a symbol, right? A tick, like a
Yeah, we could
list.
do also like that,
Or
right?
just a quote.
Oh, this?
Yes.
Yeah, that's an option. But we prefer the bang at the time. Okay,
Yeah, the
so
bang
I
is.
am trying to check each one of the parsers. So the
But
type
dude,
variable
like,
generic is
could it
correct.
be? But here's the thing: if you loaded on the REPL, did the REPL also know how to import the star? Because I don't think it did try to parse the star there. It tried parsing the S and then it failed.
Wait, you're talking about the other attempt, right? So you're talking
Yes,
about
exactly.
this.
Yeah, this.
Unexpected S, it
Yeah, so it is
says.
not a problem of import.
No, it's not a problem with import. It is a problem that is
Yeah.
it was expecting something else than we provided to. So my question is, that after the type variable we have a skip and a dot. A skip and a dot. Well, let's try to copy this like that. Uh, this. This is the parse that we want to use, and then the string that we want is bang t dot. An expected end of input. That's weird. Unexpected end of input. How that does makes any sense? Hmm. So the skip only skips comments, blocks of comments, and spaces. So the dot is not being consumed by it.
Well, makes sense. It shouldn't.
Oh, I wonder if the type generic is consuming this. It is possible. Oh yeah. Okay, that
Oh,
makes more
what the
sense.
heck? Yeah, so the dots are valid on the variables, right?
Well, as far as I can tell, we can just nuke the dot
Can we do a space?
like this.
Yeah. Yeah, so
A
it didn't
space
consume the
also.
dot.
Oh, didn't
So
consume the dot, but um.
our example was with the dot, right? I think.
Oh, you're right. We can do like this. So string, double space, this. This works.
Yeah,
This
but
should
that's
work.
kind of bad, right? Like, it should be skip dot. It's kind of bad. Should like you have to type one space only. Like,
No, and we can
dude.
also nuke the dot. I actually don't know what the purpose of the dot is anymore.
Can I see again the syntax? I don't recall what was the
Yes,
sentence.
here. So it
Uh,
would be like this.
isn't it just that, dude? Isn't it just adding a space? Okay, like if we can we just remove the dot out of the valid members to do a type variable? Like I don't think that should be allowed to begin with.
Oh, you don't want to have a name of a variable using the dot?
No, man,
That makes sense.
that is problematic. Like if we want in the future to make things like methods, this will be horrible.
Uh, for Okay, that works. Now I just need to go to the types again, do Ctrl Z a few times, and do like that. If we do like this, Commander
Oh,
is here.
the Lisp addict is here.
Yeah. Yeah.
Okay, nice. It works.
Done. Oh man, I like so much the fact that I don't need to change the functions. It's already like generic enough. Ah,
Okay, so let's see if
but
we can
oh,
parse
let's
the whole
do type for
sentence.
all. Go type for
Yeah,
all
the
now.
whole sentence.
Type for all. Okay,
Yeah.
so as far as I can tell, it should be like this.
Mm-hmm.
Unexpected I, it says.
Integer space.
Space here? No. So
After the
weird.
semicolon.
After the semicolon.
Where's the semicolon? Oh,
The
it's in the
semicolon
between.
here is in the between. It is the last
Oh,
thing.
wait, it is the last. It's after the type.
No, it's not after the type.
It
This,
is.
no, it's not. This, all of this is something, right?
Oh, there are two betweens. Oh, man.
There are two betweens, yes.
Oh, wait, so then don't we need parentheses? Oh, no, okay, never mind. It is
I think we need
parentheses.
parentheses. I don't understand why it's not complaining about not having parentheses, actually.
Yes.
That doesn't make sense to me.
Yeah,
Because it
like
is
you're
literally
parsing.
saying here.
Yeah, parentheses, parentheses, and
And
then
then
a
for
for all.
all, and then all of this in the middle, and then a semicolon at the end. That should be it, right? And we don't have spaces
Isn't it
between.
better to do the semicolon? Oh, no, but that's to limit the between. Yeah, that seems right to me.
Unexpected I. Yeah, I don't understand this. So let me read again. Um,
So open, close, and then it's a for all applied to
test.
something.
Okay. And then we do this. And remove this and put test. So it's gonna be for all, then type variable generic, which expects this, then
Mm-hmm.
a bunch of spaces, then a dot, then a bunch of spaces, then the kind. And then we finish using semicolon. So this should be it.
Mm-hmm.
No instance of.
Quack, 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 quack.
Oh, we don't have a show instance for this thing, but it works. Okay, but it
Yeah,
works.
it parsed.
Okay, that's cool. So now,
Wait, why is it a parse error? Oh no, it's an either. Never mind.
yeah, yeah, it's
Mm-hmm.
an either. It's an either. What is the type of test? This is a function. There's something really wrong. How can this
I'm
be a
not.
function?
Yeah, it should be just a parse st, right? It's strange.
Maybe that's why. How is it type checking then?
Wait. Go back there. Parentheses. Parentheses. Yeah, you're closing the parentheses. There's no like partial application. Crazy.
No, but this seems like a partial application problem. This.
Yeah, but like doesn't.
This is really
There's
weird.
nothing. Could it be that the abstraction info takes another, takes two things?
It is possible. Let's go there. Abstraction info.
It does.
It does take it takes a kind.
And a type.
Actually, it takes three things. It takes a t variable info and a kind and a type.
Yeah. So I think it is the last
Oh, I think I
type.
know what happened. I think we added the abstraction info after we did that parser,
Yeah,
right?
possibly.
But how the heck the type checking didn't find us? That doesn't make any sense. I'm
I
surprised.
have no idea.
That doesn't make sense though. Okay. Okay, so at least it is our fault then. Okay, so what is a t variable info again? T variable info is oh here. Oh, it is the thing about the name or the name ID because we need to use the random crap because of the conflict with the names. I remember that. Okay, so it's literally three things.
I
It's
love the
always three things.
description. I love the description that it's like, oh, something like the crap because of the other crap. That was the description.
No, it is the
It's
random crap because we have conflict with names, then we need to use
that's
IDs.
literally the benevirus. Like you start to degrade your language from this in
Well,
an
I
offensive
guess.
way.
Okay, anyway, we need three things. We already have this, and we already have this. Do you remember what is this?
Nope.
That's bad.
Check what is an okay abstraction info.
Nathan, do you
It's
remember why we added this? I remember there is a reason for it.
oh
I don't
okay. Then
remember
tell
which
me.
reason is. And I also remember that, well, now we know why this is a partial applied, right? This is definitely partial applied
Mm-hmm.
because the abstraction if expects a third thing, and we can't show functions, so then, well, that doesn't work. Um,
What do you mean you cannot show functions, man? Show the text of the function. What's the problem with this
no, but we
language?
already had this discussion before. Nathan already we already discussed this. Uh, Let me think a little bit. What exactly do we want to parse at the end of this thing? We want to parse a T for all. So what is a T for all? A T for all is oh, I remember now. Oh
Do
no,
you?
so that's why. Okay, no. I take that back. I know why it worked now. So pay attention to this. So this is partial applied. This. This is partial applied, which is correct. But if you take a look on the line after that, we have the type going on here. So
Yeah.
this is just for the
Oh, I see.
the type variable information and the kind
Mm-hmm.
information. Then that's partially applied, which is correct.
Yeah.
But then
Makes
we
sense.
add the type later because we want to fmap using this thing, which is composed. So this is a function. That makes total sense now.
Mm-hmm.
Okay, okay. But then the question is, how the heck we're gonna test
You know what I would have done already, right?
what?
Do notation.
Oh, do
Start
notation.
do. Yeah.
It's
Oh,
already do
it's already written.
notation.
What the heck?
Yeah, but it's using betweens in the middle of the way, so it's not kinda
Yeah.
like. But if we want to do like naive way, we can do like this. So string for all, and then we ignore the rest.
I wouldn't call that
Then
naive though.
then we pick the type variable and the kind. We pick those doing this, right? Um, this is just this. Then we do skip char this, and I would
Mm-hmm.
actually also do this, right? Then then there are the parentheses scrap, but then I don't remember why we did it in this way. We can just nuke that if we want. So
Oh,
this
for the
would be
parentheses, we can use the open and close delimiters, right?
no, this is parentheses, not brackets.
Oh yes, our delimiters are not parentheses.
Our
I forgot about
delimiters are
this.
not parentheses. Yeah. Okay, and then we can just do, I guess, pure this, and
uh,
that's kind of it. But we need to change this
don't
something to something else.
well just add the parentheses as well.
Type variable kind. And I guess this would be enough. But this is just this should be exactly the same thing as we did before.
Well, you forgot to add the parentheses on the beginning.
Do we need that though?
Well, I hope we do.
Oh, you hope. I see. So this is gonna be char.
Because we do that everywhere, so it would be strange that suddenly we don't.
um, and then skip, and then
No,
char, and
wait,
then
wait.
close.
No, after the type P, right? Not there.
After the type, where?
Like on the 54, sorry, 46 instead.
Oh, you're right. You're right. This is not in here. This should be here, like that.
Yeah.
Yeah. So, but theoretically, like I said, this should be exactly the same, but it's wrong,
It's
of course.
it
So
is
let me
readable though.
figure out why it is wrong. So expected this, found something else.
Don't you need the type of the verb, the abstraction?
Don't you need what?
The abstraction info. We're not building it with it.
We are here.
Where? Oh, okay, I see.
Yeah. Okay, so that was the problem. We didn't need pure there. But this should be exactly the same thing as I said, as we were doing before.
Yes, I agree. It should.
So
The question
type for
is
all.
it?
Oh,
Parentheses. Parentheses,
now we
right?
are missing parentheses. Ah,
It works.
it worked.
Good.
I have no idea why, but
Oh man,
okay.
pure stupidity. Keep it this way. Keep it simple.
Uh, okay. Now that this is working, we can go back to the program. Um,
Yeah, I added the this
we need the
the
extra parentheses now.
yeah.
So this is gonna be like that, and we also need the dot, like this. So theoretically speaking, we should be able to just build this. We still have to figure out the bug about the declarations not working for some reason.
All this star, right? And I think it's just a case of empty.
Again, didn't work. What the heck is going on? Are other things working? Yeah,
Can you add the
I'm so
print?
confused.
Oh, dude, I think I know why.
You think you know?
Add the print in on the after the. Let me do it.
Oh, that explains a lot.
Yeah, but it should. This function here should print, right? But unless it's wrong. Let's see. So this return is unit, so it should be unit.
Are you sure about the
Wait,
amount of
yes,
brackets? Okay.
yes.
Okay, so
You
let's.
cannot say parentheses. Right?
Okay, nothing. So I have absolutely no idea what's going on there.
Well,
Wait!
hmm.
Okay, but it's parsing it like this. So a
Yeah, this.
function inc.
Yeah, that's the first one only. Which is
Okay.
right.
Okay, but then that's why the ABC is not doing anything. Okay, so let's go monkey way again.
Monkey way.
What the heck? What are you
Oh,
talking about?
uh,
Did I add this to
on that.
the
Wait. Do we need a bang here?
type for where?
Try.
Do we need a bang there, you say?
Yes.
Oh.
I think we do.
That makes more sense. That doesn't make sense why the
Yeah,
main
doesn't
function is
explain
broken.
why. Yeah.
No. No, 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 no.
Where is that breaking? Column 105.
5. We can see that in here. We don't need to count, Magetta.
Yes, I know. It shows the number. Here.
Wait, that means that it's not working. The
Yeah.
or we're counting the brackets wrong. But I don't think that's the case.
Oh, wait. The brackets are wrong. No. Wait. Are they?
We should we
No.
should we
This is the
should
print. No, that's right. This is the print, and this is the other print. Yeah.
should be like that, I guess. So this is one. This is
Let's try
another
to do
one.
something simpler here, man.
One parenthesis is because of the for all, and another one is because of the other thing.
There.
Oh, wait a sec, man. Wait a sec. I want to check how the list stuff is being done. Okay, so the list stuff is a type P. A type P can be a type variable, right? Yeah, it can be a type variable. And a type variable can be a bang. It needs to have the bang as again. Okay, so yeah, I don't have any idea. I love SQL.
Try this, yes.
Well, I also want this. No, this is still the same thing.
Yeah, so it is a problem on the global declarations.
It is a problem on the global. No, but it's not parsing. It's almost like skipping it, you know?
You're implying your comments? Did
No,
we
but I tested exactly this behavior before in why why is it just not working for this case? Is the comment one working? Yeah. Yeah,
Dude,
so I
what
have
the
no
heck?
idea.
Why don't we try the comments though then? Can you go there?
Here?
Oh, but they're not declarations, right? They're just expression
No, but they
declarations.
could. Let's pick an example of, I don't know, fun. No, not fun. Functions. Also no funs. Yes. Okay, so let's pick this. Let's go to comment. And let's, instead of doing print integer that, we just do add in here. Yeah, of course it works.
Add another one. Add two.
Okay, add another one. Comment. Then we can. Did I save? Yes. Yeah! Of
What
course
the
it is
heck?
working though. I tested. I know
Can
it
you
is.
can you add another expression on the? Let's try this then. The
I'm guessing that at
following.
some point we are doing something really, really wrong.
I think I might have an idea. Try this.
Okay. Oh,
Aha! So that is the issue.
okay. So it is because of the parsing of multiple stuff in the declaration. In the declaration. Oh, I know why.
Do you?
I know why. Because the abstraction parsing is not being used by the declaration parsing.
Oh no, dude! That's just a lambda, right? Oh man.
Yeah, so this is a many one here.
Um,
And it's exactly the same problem as before. So we need to have a program at some point in here.
yeah.
So
So it is. Let me follow you.
I think we
So the
need a
body.
program,
Yes.
eProgram.
There. And let me see.
How how
What
far
is
this
this?
error went?
Actually, here, right? Oh no, the fun body is the whole. No, but dude, like, oh, okay, we're just building.
Yeah,
Yeah, I
we're
think
just
that.
building in here.
Yeah, I think that's it. Yeah. Oops, sorry.
Okay, so let me save. Let's build. Oh, okay, now something else broke. Line 42. Okay, so now this guy is wrong, which is cool. Why is this guy
Well,
wrong?
look at the message. What does it say?
Um, wait a sec. No, it is saying something more complicated than I think it is.
It is saying an arrow or something.
No, it is saying that, oh, I was
Type expression
expecting I
to
was expecting
declaration.
this and I got this. So
No, no.
something is partial applied.
Dude, look at the first one up there. Expression to declaration, but you got a declaration.
No, I think it's the opposite. The expected was to have a declaration, but you
Okay,
provided
it's
me
the
an
opposite.
expression to a declaration.
Yes.
So something's being partially applied on this mess.
Well, I don't know if it's partial applied. I think it's just partially applying would be consuming one thing and then mismatching because you have a thing that is a function. It's not the case, right?
The type of body is a list now, right?
Yes.
Is a list. Okay. So the first guy in doing the currying, because we are doing a curry process in here with the fold.
Yeah.
The first guy is making abstraction.
Oh man, I forgot about that. That sucks.
That sucks, you say.
Because we are making the entire thing. Because think about this, like to curry, you would pick the body, right? And then delegate the body for the other functions. For the yeah, and just like adding the parameters in the fold. But if we are doing this,
Let me take a look on the abstraction
oh
again.
no, but dude, that is right. Look at the fold there.
Look at the fold there, you see.
Like the fold is correct, like the fun body. It is just saying, okay, go find the last of the thing. So they need, right? Apart from the last, I guess, because it's reversed, so it's fold R, and then you build from the arguments, and then the last thing inherits the body of the function. Like is actually the body of the function, right? The rest is
Another
just
in,
for
another interesting take. Another interesting take is that fun body is not being used, right? If you
what?
highlight this, it is the only instance of being this using this name.
Dun 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 dun.
So this seems bad. So let me think.
Dude,
So
isn't it just copying the other type and just pasting
curried
there with a
arrow.
declare function?
Where curried arrow lives? Oh, here. Oh. Okay, okay. So fun body is useless.
Isn't
My
it just
guess.
copying? Dude, like, what? Isn't it just copying the abstraction and changing the first thing to be a defunct with extra parentheses?
Just a sec. Okay, so I want you to pay attention to something, Mageta. Do you agree that fun body is not being called anywhere else in this function?
Yes.
Do you agree that first is only being called by fun body?
Mm-hmm.
Do you agree that fun is only being called by fun body as well? Hello?
Yeah, I can think.
Yeah, so if that's correct, then I think I should be able to just do this, and the thing would still compile. Oops. Oh yeah, but I changed the body to be a list now. Okay.
Dude, why are we doing this to begin with? Wouldn't it be just getting the same thing that we just did, pasting there, and adding the defunct on the delimiter
It
instead
would,
of
but
lambda?
uh,
Yeah, just paste there, man.
I'm so confused right now. Wait a sec. Because if you take a look on here, if you take a look on here.
Oh man, that's a waste of time.
No, that's not a waste of time. Just take a look on here. Do you see this line here? This is the return of this. Do you agree?
Yes, I do.
No, no, no. Stop typing. You will understand the problem. Yeah, I want you to understand the
Dude,
problem first.
why would I understand this shit, man? Like,
Because it doesn't make sense. It
well,
doesn't make
dude,
any
like
sense.
I can't even read this code, man.
No, it
Like, why
doesn't matter
bother?
if no, it doesn't
Dude,
matter. It doesn't
man,
matter if you
I refuse to do this, man. We literally just fixed this shit, and we just need to change a word to make it work. And you gotta go through all this painful process just to do this,
I
man.
want to understand how this is
Oh
making
man,
any
like, screw
sense.
it.
That's what I want to understand.
I'm literally ranting right now.
Yeah, you're ranting for no reason. I just want to understand why
Okay,
is
you have
this
to take your
here?
time.
Why is this here?
I don't know, man.
Okay, so you don't. Okay, so then you can continue doing what you're doing. You don't care. Okay. I want to discover how is this compiling. Uh, Let me take a look again on the types. What is a declaration of a function again? A declaration of a function is a text, a type, and an expression. Huh. Is a text, a type. Okay, so this is the type. Where the heck is the body of this? Shouldn't it be this? Or in this case, fun? Did we delete something as accidentally?
I can't even read this, man.
Okay, that's not a problem. But what is a problem is that that doesn't make any sense, and I want to know why. So, parser declarations. Oh yeah, so we deleted something accidentally. So from body is here. That's why this matters. Okay, okay, now everything starts to make sense again. So this is just the type. Okay, this is just a type. This is the name of the function, and this is the body of it. And the body is here, and this requires this, and this
Well,
requires this.
if it's the same type, of course it wouldn't matter. Like,
No, no, but
if
this
it's
was
the
like
body,
this. We were discussing, and this was like this.
this is like this what?
this was without this being typed in here.
Yeah, it was body, which is the same type.
No, it was this. It was empty. And
So
then
that's why it was saying it's a function.
exactly.
So
But I didn't do that. Did you?
it didn't do that. What do you mean?
I
Add
didn't
that?
delete that. I don't know what happened there, but it's fixed now.
I don't
It's
know.
working. Um, okay, still nothing. Okay, it's still broken. It is still broken. So what I want to do is go to the example again, go to the program. We are doing something wrong because it's now compiling and now we are 100% sure that we are using the program with the alteration for declaration of functions, right? And this thing is already using the many, so this is a list, and it's already having the implicit program, which is a list as well. I get it?
Yeah.
So so let's go to the REPL and copy paste that function again. Oops. Like that, and then like that. Yep. So something is not correct. Many expressions. Unexpected. Expected white space. This is column 86. What is column 86? Is this? No. It is this? Yes. Oh, there are spaces between them, dude. Okay, that makes more sense. And that didn't
If
matter before, because before we only had one. We also need to change
no, it
that in the
makes sense.
abstraction.
That makes sense. Let me add that already.
Okay, here.
Where's this? Oh, save. I think I cannot
And no
save.
space, no skip, no spaces, only skip.
Oh yes, I forget
Because
about the
then we
skip.
have comments as well.
Wait. I don't think you need to add one in the beginning though.
You don't think we need to add one in the
Yeah,
beginning?
because it should already have on the other option.
Oh yeah, that
Keep
makes
up
sense.
there.
That makes sense. Let me remove it from here as well. Oh, okay. So I guess it didn't save. Wait. Couldn't match expected expression 60. Expression 60, expression 60. Which line is saying? 50. 50 is here. Well, we don't know the type of the body at the moment.
Oh, it should be a list if it's coming from this many.
It should be a list, but I will
Oh,
also put parentheses in
yeah.
here.
What about parentheses here instead?
Parentheses there, you say.
Yeah, because of I fear possible ambiguity with this. Let's see.
The funny thing is that it's saying that couldn't match unit with expression. So at some point we are just throwing unit at it.
Yes.
Well, that's not a problem. I can fix this. I can fix this later. Which time we already have here? 1 hour in. It's already 9:30. Do you want to continue, Maggot?
Well, I have time. I wanted actually. Let me check with Vinicius because I was going to do something with him.
Okay, no problem. Expression P. Oh.
What? Oh, okay. We were ignored. Okay. Okay, that was dumb. That was dumb.
Yeah, and that's why we spend most of our time in parsing Nathan, because we are dumb. I say this all
Change
the time. This is not hard. This is one line of code.
change the other thing. Yeah, there. Oh, we are doing it right there.
Yeah, no, but the expressions was the problem.
Yeah.
It is one line of code, and then we spent 1,000 hours on it, and then you complain.
And we will probably never have
Okay,
enough time. Unless
okay,
we rewrite it in Rust.
okay. Now we have a type problem.
Unit that is not okay. I know that I seen that error. It's like that error message. I remember being horrible because it doesn't tell me anything.
Cannot do a type application with a value of type for all.
Yeah, but you try to apply something on the wrong arity, I guess. So let's see on an example.
Do we have examples for alls? I think we never did one.
Wait, the program is not saved, by the way, the file.
Oh, that's a good call. No, same thing.
Let's see. So it is complaining about this, I think. Try.
Okay, I'm not even gonna see the same thing.
So it's not the print.
And it's not the
Is
parsing.
it is this? Oh, dude, wait. This okay? This is like passing for the list, right? So there
Oh,
should be a
now that we
list of
have
stuff.
parsing working though, we can just throw it in the wrapper and ask for the type.
Oh yeah, good.
Aha. Okay. So the type of that is this.
Apply integer there. That is wrong.
Yeah, it should be list of integer to unit, I guess.
What is the print type? Do a print type of the print. So it is the same. Oh wait, I think I yeah print st. Print the st of both the print and the. Oh wait, not the st. I think.
Yeah, but I
Yeah,
think we can do what you said with print though.
yeah, we print we can.
Isn't this what Nathan was asking the other day? If you can
Wait, no.
apply a type and then the list will work correctly?
Let me look at the prelude here.
No, the ST is
Prelude.
already here, guys. I don't know what you guys are talking about.
Let me look at the prelude.
I think that's kind of it though.
So the type for print is a for all, abstraction info, t, star, and then an arrow. Oh wait, it is an arrow. Could that be the issue? Like print what is the type of the ABC? Only ABC. It's a
ABC is
for
wrong.
all.
Nathan says that ABC, the type
Yes.
ABS is the correct. What? ABS? What you talking about? Do you mean ABC? Abstraction. The type of abstraction? ABS is wrong. Okay, so the abstraction, this is wrong. Is that what you're saying? Okay, so he's saying that this is wrong. Okay. Then the question is, wait, the
Yeah.
type is wrong.
No,
What should be the type?
the type of X should be wait. Uh, that should be the type of the argument. That's X for all.
It's a for all. It should be a type abstraction.
Yeah, that's true.
It's a for all and should be a
There
type
should be a
abstraction.
E-type abstraction before, right?
Oh, you mean
Oh,
here?
after, sorry. Yeah, after this, an E-type abstraction.
After the E abstraction? Wait, now I am confused. What this should be then? It should be like this, I guess.
Just a second. It should be like, look at the E-type application in the application. That's the same case. Just a second.
No, but then we have a huger problem then. A bigger problem. Huger. We have a bigger problem, which is that the declarations always expect to be abstractions. They cannot figure out by itself that, oh, this should be any type abstraction, right? I guess that is what you're talking about, Nathan.
Well, I thought that was happening.
Are you using an expression parser? No. Well, in the body of the function, yes. Wait, why? Because that doesn't make sense. A function is not an expression, right? It's a declaration. On the declaration. Well, I am, but only in the body of it. Not in the declaration of the parameters. Like the arguments of the function, it is assumed to be any abstraction. Look. Show me the example of what you want to parse. This. I guess the problem, Magita, is that do you agree that this should be converted to the E-type application? E-type abstraction, I guess?
Yeah.
Yeah, so that's a problem. Because the declarations are assuming that you're always going to have an abstraction.
Yeah, makes sense.
Yeah, so the problem is that. That's the problem.
So it was actually good that we tried to do that.
Well, but I agree that it is good, but for the sake of testing the program, because that's the initial intention, I guess,
All the comment, man.
we could take.
I
Well,
just
we,
put
we
like
don't have we can't have E-type applications or E-type abstractions in here. So
just
this
put the integer, man.
no,
Whatever.
this can be a list of integers.
Yeah. Okay.
Well, we're not using the list, so I'm gonna put an integer, yes.
Yeah.
And then you just do 5. It's easy to fix. The fold should check the parameters, and then you wrap it either
Yeah,
ABS or type ABS. Yeah, that's exactly what we were doing with the other one. Do you remember that? What you said, it's exactly this. The problem is that, well, that's not a problem. I will work on this code to make it abstracted enough in order that we can reuse in both places. Then we're gonna be good to go. That's not a problem. That's okay. In the meantime, we just can test we want to test the program. It is still not doing.
Wait, is it not doing or not printing? Oh no, it is not.
It is not doing anything.
Wait, but it didn't. Okay, the comment it ignored as well.
Yeah, but I'm not assuming it's wrong as well. Okay, so something in here now is wrong. Oh, the double parenthesis in here, I guess?
Yeah. Why it didn't break though?
Exactly, that's a good question. Okay, now we have the ABC there. So I guess if we do this.
Yeah.
I love SQL. Hello. Okay, the implicit program is working. So now let's make a function that uses, I don't know, use the program explicitly. How can we do that, Magita?
Wait, do what? Sorry?
We tested the implicit one, right?
Yeah.
Now we want to test the.
No, do an if.
Do an if, you say.
Yeah, do an if and with 2 prints.
Okay, so it's gonna be if, right? If true, for now.
Oh, you can do x equals 1, whatever.
Yeah, that's not a bad one. X equals 1. Then we're gonna do a program. And then we can copy these 2 prints. Do you prefer tabs instead of spaces?
Yes.
I don't know how I feel about that. I am already lost for words in this program, but I think it's in here.
I think our else. I think we don't have a.
We don't have the when yet.
No. What I'm saying is like, yeah, okay, the when is the if with only one clause, right?
Yes.
But I think we can keep an if and just like make the else optional if this first type is unit.
Wait, I don't. Can you repeat why or
Like,
what you said?
well, like if it's unit, then the else would also have to return unit, right? So it's no point. Like, if ABC, blah, 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 I don't know, true, then, and then if you do this, then you don't need to do an else. Like, because the first branch is already unit. So it's the same as not having anything.
Oh, this is a syntax sugar for the when then.
Yeah, for the when
Uh,
or for the if, that's what I'm saying. But I think making this explicit on when is better, like to force type. I love no, dude, remove shit. I hate MySQL. I hate MySQL.
Why? What do you have against my SQL?
It is buggy, slow. It is the worst.
Remove that shit. It was like
Dude,
immediate.
man, Belani showed me a link today
And
comparing the
nothing.
DBMSs. I literally got scared of MySQL. Like, I don't
You
know how
got
people trust it.
scared, you say. I think we're missing a bracket.
Let me see. Let me
I
scan.
think we are missing one. But the parser should say that. Why is it not
One.
working?
Wait. One, two, three.
Yeah, there is
One,
one for the
two, three. No,
program.
remove one.
One for the print, one for the
Yeah.
program, one for the if, and another one for the defun.
For yes, that's right. Yeah. Yeah, dude. Oh man, the highlighting.
Unbound variable program
Oh,
in
you
the
gotta add the
environment.
bin list. Bin list.
Unbound variable.
Yeah, you gotta add the
Oh,
bin list,
I see
right?
what you mean. So you're talking about this bin list here. So you cannot have a variable with that name. Ah, okay, so we
I love
used
SQL
5.
Server.
So now we're gonna change this to 1.
Awesome, it works.
Program working.
Yeah.
We discovered 2 bugs. The first one,
Make an issue on GitHub.
yeah. Yeah, let's do that. Why not? So, we discovered 2 bugs.
We have issues, man. What the heck?
Yeah, we don't use. Oh, I need to log. Oh
Oh,
no.
you're in the other browser.
Okay,
Yeah, I
so
can do
can
it
you
later.
do that?
Yeah, I can.
Okay, so the first
So,
bug is that
wait, let me open it.
the parser is not
Give me the example, by the way.
oh,
Throw it
this
here
one.
on the
Just
chat.
copy this code and remove one bracket of the ABC at the end.
Oh, I see.
Like
So,
this. If you do this, the parser is not saying crap.
okay.
Yeah, it's not saying crap. Okay. So um yeah, so there's that. You said maybe you shouldn't. You shouldn't do what, Nathan? I didn't get the context at the time. Are you talking about refactoring the expression
I think
parser?
it was making the function the same and just reusing it.
No, no, it's not going to be the same. It's going to be
Like
using
reusing
same
it.
parts.
Yeah. Balanced brackets.
What you said, Lemus. Oh, so you don't think we should reuse the parts of the parser of the type abstraction in the declaration of functions? Maybe you shouldn't. Can you enumerate reasons why? Because it can be a bad abstraction. Yeah, but well, because it can be a bad abstraction. Yeah, of course. Almost everything has a potential of being a bad abstraction. So, do you have any better idea? To Because for the E-type abstraction it works. So why is that bad? That's the point. I don't get it, but okay. So the first problem I get is this, right?
Wait, let me untype in just a second.
Okay. Hmm.
Are people really talking about politicians not paying tax? Like, dude, it's an illusion to think that politicians pay tax.
Where does that came from?
Listening to the
Did that
television,
came from?
to the brainwashing machine,
Okay.
also known as television.
Um. Well, Nathan, if you have a better idea for better abstraction for that, please share. Especially because it already works for the other one. So I want to know why sharing is not good. You can try it. If you feel it's a bad abstraction, don't do it. Well, let me take a look on exactly what is this. What would define a bad abstraction? I don't know how to explain. Well, a bad abstraction is an abstraction that, or it is doing it is doing a very convoluted way to solve the problem, right? So that I would consider that a red flag. And the second way to define a bad abstraction is if you find a one that is another abstraction that has better benefits or less drawbacks.
Labels. Let me add the label bug.
Doing some weird config input as argument.
Okay, we have our first issue.
Okay, the second issue is,
Is that for all, right?
yeah, no. It is that we need to be able to have E-type applications and E-type abstractions. Oh, that doesn't make sense to have E-type applications,
Type
right?
up
So type
abstractions
abstractions,
only.
type abstractions in declaration functions. Which shouldn't be very hard to do. You just need to
Mm-hmm.
refactor this code. The pieces don't evolve together. Second, doing some weird config input as argument. Weird config input as argument. Can you explain the second point again? Well, rephrase it at least. I agree that if the pieces don't evolve together, that's a bad abstraction. But this was a decision because I remember saying this when we did the declarations. I said, "Man, this is exactly the same as the parser for normal abstractions, but we just don't have the type abstraction case." And then we decided to just copy paste it instead of refactor because of my get style. So, so the pieces don't evolve together because we chose so. So I want to understand better the second point, doing some weird config input as argument. And by the way, after having, I think that the piece of code that I will refactor will be this, like these shoe and these lets. I think those two groups being out, done. Actually, I think I can put this fold with this let, so it's gonna be even better. Because it's exactly the same. The only thing that changes is like, oh, one has lambda and the other one has defun. And the other, yeah, even the column for the type is the same. The difference is that I think it's not optional anymore. In the abstraction, it is optional. The declaration of a function, it's not.
Okay, done.
Okay, you created there. Okay. Unbalanced limit, no parsing, no error. Yes. Function declarations do not support E-type abstractions. Yes. Yeah. No, that's it. So I don't even remember anymore what was also in our list of doing. Do you remember, Magetta?
Wait, what? Sorry.
Yeah, because in the beginning, before Nathan joined, we discussed about what we're gonna do today, and then I said, well, we can start. Oh, we need to discuss how to do the mutability. Oh yeah, there's that.
Oh yeah, I don't want to do that one.
Why?
Oh man, that would bring so much complication, man. I think we should focus on finishing T's first and aliases,
Well, the aliases is Nathan is here, so he can
and
help
then
us.
and then trying to fix all the rest of the, like, just not fixing but checking our scopes before we how they behave before doing the mutability bullshit.
My guess, this is just a guess. My guess is that when we add mutability, we're gonna have to add new nodes to the expression and the type, data type.
We can do
That's my
like
guess.
explicit, I think, declaration like F sharp does.
Yeah, I don't
Like
see why not. Actually, I think it's better to have explicit
but
because the
it
standard is
still
immutable.
still I don't think it is just like straightforward.
Um,
But anyway, let's finish the alias then.
well, the alias is well, that's a problem because we're gonna have to. I remember that we finished doing this function here, which basically picks in a type in an environment, checks if it's a placeholder because we already discussed that the parser cannot know like beforehand that oh this is a user defined type, so I should parse it like so. And then we also added a new parser here, which is exactly the same as the type alias, but it has a character specifically targeting to identify that oh this is a type alias placeholder. And then what I don't understand, I don't remember, I don't think Nathan explained, but I remember Nathan saying that we need to replace, to put this find placeholder alias in a lot of places. My understanding is everywhere. So why do we need to do that and when do we need to do that? That's the question. So, Nathan? Because it's cute. I don't know what you mean. I definitely don't know what you mean. Um, so, what are the situations in which we need to do a lookup into the alias context? Every time you have a type. Every time you have a type, you say. Literals, for instance. Where do we need to do a lookup? Because we are returning the type here, right?
Yeah, the
What?
literal you already know the type actually.
Yeah, but no, but I want to understand what he means with the every time you have a type. Because the
Yeah,
type
like
checker, we
for
are returning
example,
types all the time.
yeah, for example, like let me think.
E variable.
Let me pick. Okay, a variable. I don't think it's a good one because you're already picking the on the environment.
Every time you have a type, you don't have a type there. Every time you have a type, you don't
Let
have
me
a
go on
type.
Linux. Yeah, like I think I got him because every time you have a type, you have to assume it is not a. It's possibly not a type. It is something you gotta look for in the context again. Because it could be just an alias, right? We gotta check if it's a T alias and then if it's an T alias, because a T alias is also a type, right? So we look from that on the
No, but I'm
environment as
still
well.
very confused because I don't know. I need an example to understand, I guess. Can you give me an example of that?
Let me think. The literal. I think you can. Can you go to the ST of the literal? Let me take a look.
Here.
Uh huh. So a literal just assumes those to be types. Okay, so the literal we would have to add an alias for that as well because actually no, never mind. There is
Uh,
a
no,
T
but
literal, right? There is a type for that. I don't remember how are our types.
here
Let's see.
we don't have a group
Yeah, okay.
grouping stuff.
So I think it's he's here, but I think it means on the alias, like because if it is an alias, you gotta look again, right, to see if you have actual a type that is not an alias. Nathan, are you
Wait,
trying to say
wait, wait,
something?
wait, wait, wait.
Oh,
Oh, there he is.
Nathan. So I want to understand I want to understand the situation in which we need to look up to the alias context. And
so
then
go
you
to the
see,
expression.
go to the expression. Ah,
Every node there that has a type, you have to do a few things like required, like every time. For example, you pretty much always have to check the kind. Even if you don't want to enforce that the kind is a star, for example, still you have to check it to see if it's well formed, for example, right?
mm-hmm.
You have to do the same with the alias because every time you have a type, this type could be an alias. And since the parsing only returns the alias placeholder, you need to do the substitution of that by the actual.
Oh, I see what you mean. So every time we have a type, we need to do a pattern match to see if it is a placeholder, because if it is, we need to do a lookup.
Well, not a right? You can just like do a function that does that for you, but yeah.
Okay,
Yeah,
now I
that,
understand. Because I
mm,
forgot. I need to remind myself. We have two type aliases. We have the real one and the placeholder one. Ah, okay. Um,
I think it's better to make a function and then you embed that on the.
okay, so it is this function then. So, but it is
Mm,
not this function not correct per se. I just like
Yeah, it
this.
is not. You have to do recursively, right?
You need to do recursively, you say.
Yes, because for example, if you have an arrow that has a type placeholder alias inside,
mhm.
then you have to go inside, right? Like recursively.
Oh, so all the ones that have types inside them as well. Which is gonna be the anonymous record, arrow, t variable, t for all, t application, t abstraction.
Almost all of them, you mean?
Um, can you have an alias inside an alias?
Well, yes.
Because if you can,
Hey, can you go further on that?
yeah. So if you have an alias inside an alias, you do
What
something
is the
like,
node? Show me the node. The 154, the line?
T
yeah.
Yeah,
alias
you
text type.
usually, yeah. There are a few things that you can do, but I would say that you usually would not, because something that you can do is when declaring an alias, you totally unwrap the right side, right? So there is no alias left there.
Yeah, if you have more, then you don't know when.
Wait, I'm confused.
So
What do you mean by ignoring the right part?
no, I didn't
No,
say
not
ignoring,
ignoring the like
unwrapping.
you. Yeah,
So if you have an alias on the right side of declaring an alias, you can just unwrap it, like you have no. Well, I'm not sure.
yeah.
We
You
have to
would.
see. The
I
main
think.
thing that we have to see is regarding error messages. I'm not sure if you will need the thing inside on the right to be an alias. Error message will tell. I mean, if you want like better error message or not, right? That will dictate if you need or not.
Well, I the reason why I don't well, do I remember this? The reason why I added this is because of the error message. I remember that as well. But there was also another reason. Because I remember being related to the reduction here. But I don't know if
Because you
that
don't
holds
want to
anymore.
receive the environment there.
Yes.
Yeah, you will not need the environment there.
Yeah, but if we don't have the type here, If you only have the name, in my understanding, we would have to do a
You
lookup.
mean the T alias placeholder, right? See the error there.
No, no, no. The T placeholder, yeah, but I was discussing with Magita about, oh, the T alias only has a text. Why doesn't have a text and a name in a type?
It always have a type.
No, it didn't. If you go back to the previous commit when you guys added this, it was
Okay.
only this.
I thought
That was a completely different thing, man.
Wait, what?
Yeah, you don't need. Yeah, that was a completely different thing. You don't even need to remember that.
I'm confused. It is literally written here.
Let me see. We
The
need a
reason here
way.
is because of the error messages, and I agree. This is another
No, no,
reason
no,
for
no,
it.
no. Yeah. So you can delete this error message. This error message, we already did it. Like you can read there, like the everything that is after the semicolon there. That's
yeah.
what we have done, right?
No, wait, that's what we have done, but well, I am
So
just trying to understand the
it was
reasons.
a to do, and now it's a done. So we can delete.
No, well, this is not what I was. This is not the point that I
Yeah,
was
the reason
making.
is
Okay.
before we were doing some kind of reference, right? You just carry a name, and then when you need, you just take a look on the context. And yes, you would need the environment on the reduce there. You
Oh,
would.
okay. So I was not crazy. So you would need in here.
Yeah, on this old
Okay.
way, you would.
Okay. Okay. Okay.
And the old way caused a bunch of problems.
Okay. Okay. So
No,
let's. Okay, but then let's fix the function. So this is the find, I guess. So if you are a placeholder, well, right now the way that is implemented is if you are a placeholder, we do a lookup. If we don't find it, we just throw an error. If we find it, we construct the real one. Is that how it's supposed to be done? Aside from doing the recursion.
I guess so.
Okay. So then we need to do the recursion for all the other ones. So find placeholder. Let me copy the ones that we need to do. So anonymous record and this, all of those. So we need to do for those. Uh, so which ones do we need? All of those, all of these. Okay. So find placeholder alias. If you have a type, if you have an environment and you have a T arrow um, that has I don't know 2 types, we need to call this guy recursively. So do I don't know. I'm out of names at the moment, so it's gonna be this. Find no. Find placeholder alias with the same environment, but doing it individually, like that. Okay. Then then after that, what? We construct the same arrow, but with the alias fixed. Hello?
I'm not paying attention.
Mhm.
Okay.
Yes.
Okay. So find placeholder alias using a t variable. A t variable has a t variable info, which has two possible cases. So you need to do a case there. So view split
Just
right.
return it, man.
Wait, can you repeat that?
If you don't have a type inside, just return it.
What the heck? Here. Okay. Wait, I'm still confused. What you saying?
If you don't have a type inside, just return it.
But we're always gonna wait. What do you mean by don't have a type inside? You mean the t variable?
Yeah, this T variable has a type inside.
Um. Oh no, the t variable only has a text or an ID with the random crap.
A variable, right?
Yeah.
So just return it.
Okay, so it is already this case here. So next is a t for all.
Yeah, but that will cause a problem, right? If you do the catch-all cases.
Ooh, which problem? When you add
The
a new type
problem
here?
of, yeah, and that could be a terrible bug.
I agree. I totally agree. Um, well, I'm gonna do the copy pasting later then. So the
Maybe if you
next
had
one is a
like
T for
a
all.
decent pattern matching, that would be a lot easier.
I agree that the pattern matching could be better. Abstract info. Abstract info has one of those. Okay, so it's gonna be a T for all. Abstraction info. Then we have a T variable info that we don't care. We also have a kind. Do we? I don't think we care about the kind. Is that correct?
Don't.
Sorry?
We don't.
Okay. And then we also have a type there. Then we just call recursively, so it's gonna be this. Find placeholder in alias. Passing the environment with a T. Um, and then we just, it's literally always this, right? We always reconstruct the same thing, but replacing the info kind, the alias with whatever we got. Okay, next one is the T application. I guess this is gonna be so similar to the arrow, I'm just gonna copy paste. So if you have a T application, you do both, and then you just do this. And the last one is kind of similar to this, but instead of that, you do this, and instead of that, you do that. Okay. Okay. I will do the copy pasting later. So what now? Now we need to put this function all the way through the type checking expression, I guess. Is that correct, Nathan?
Can you repeat?
Yes. So now we need to go throughout the type check expression function cases. And everywhere that we have a type, we need to call this.
Yeah.
Okay. Okay. Oh, I forgot the anonymous record.
Type on the node, right?
What? The anonymous record?
No, no, no. Every time you have a type on the node, like not like every type. Every time you have a type on the node.
Wait a sec. Ooh. This one is fancy. Um, type names.
A
This
map
use
is fancy.
um it is a no, it is not a map. It is a map M. So I'm gonna make the function here, but it's gonna be type names, and we literally can just t anonymous that, and now it comes the thing. So I'm gonna do a function there. This function needs to return the, so it's gonna be a map
Dude,
find
who
placeholder.
adds like salad to sandwiches? Sandwiches are not made to salady.
Oh, I like actually.
I don't know.
I like. Okay, I think that's it. I think that's it. Wow, this is very fancy.
There is something wrong there. You don't have a name.
You don't have a what?
Inv.
Oh,
And why do you have a map there before the
because we have two
find
things to map,
placeholder?
right?
We have two things to map.
Yeah, we have to map a list and a tuple.
Oh. Wait. So the functor of a pair by default is the second one?
Yes.
Oh, okay.
But I just figured that this is kind of you actually need to get the values. What's gonna be the name of this? No, this TS.
The values.
Yeah, we need to do
Oh,
like that.
okay.
So pure um, unknown. Probably there is a way of doing it in one line, but I'm not gonna bother.
Wait, do you? Like this already like returns the result, right? So
Yeah, but that's a
oh,
problem.
because it's inside the anonymous. Oh,
Yeah, the anonymous record, it needs to have the listed site that is wrapped in the result. So
I
I need
see.
to do like that. But probably there is a way of doing it in one line. I'm not gonna bother right now. Anyway,
Well, that's the bind, isn't it?
that's the bind. That's the bind. Yeah, that's the bind. Oh, that's great, Nathan. So this is this equal that, and then we just grab the
Oh
this.
no, that bind no.
You're expecting something different?
Well, on the other side, right?
Well, to be fair, because the constructor is a function, I think it works in whatever in the way that you want, like that.
Oh, why is the matter being a function?
Well, because if this was, I don't know,
Bind always takes a function, right?
the bind always takes the functions, but sometimes, I don't know an example right now, but sometimes I have to do things like this instead of doing point free.
Yeah, that's what you weird.
Anyway, I think this is gonna work. We can discover really well. We can discover right now
Wait. So are you missing any case? Like, why you still have the last case?
because I'm gonna do the other ones later.
Oh.
That's a good sign. Didn't break immediately. Okay, so it did break, but later. Cool. Uh,
Just to give you some.
let me think. Let me think. Okay, so I need to check the Hugo. Help me. Mapm. So our T is a list. Our M is a result. Oh, so it's in reverse order. Great.
Dude, I really do think that if Victor started programming like functional with Haskell, he would have given up. Like, he would hate it.
Yeah, weak people give up easy.
I don't know if that's weak, that's just the philosophy.
Well, the philosophy is that types are king. That's the philosophy.
No, that's not philosophy.
Yeah, it
That's
is. Even side effects
maximalism.
has a type.
I'm not judging if it's right or wrong. I'm just saying it is a mismatch between the philosophy of Haskell and what he's used to. Different. That has nothing to do with like being.
No, I think if you drop just because it's very very different. I'm not saying like, oh, you should start with Haskell because I like Haskell. No, I think that you are dropping just because it's very different. Then you need to take a look on yourself in the mirror.
I don't think it is just because it is different.
Why not then?
Oh, I'm just saying like it is a mismatch. If and you go for like Haskell and
Your
you gotta
microphone
understand
is
what is a.
cutting.
I think I was talking in the wrong place. And you gotta like look for something. Okay, like how do I use a bifunctor? You gotta understand like category theory. Just to like basic stuff. I guess that's like a scary point for like.
Well, I would argue that you don't actually need like.
No,
No,
I know you don't. You can do functional programming, with this, but I'm just saying like having the names there just like is a major shoe.
Nathan, you're talking about the valid reason of just being different. You would just potentially not want to learn a potentially better tool just because it's different. That's a bad argument. That's a horrible argument.
Nobody's making this argument.
No, this is saying that it's a valid reason. If valid, if the meaning of valid he
What?
means reasonable, then I think he's wrong, Nata.
Wait, he's talking about what you said, man.
No, he's talking about. No, I repeated just to him to confirm. He
Wait,
said that a valid
I'm
reason to
confused.
not learn it is just because it's different. I'm gonna repeat a third time just to be 100% sure. So, do you consider a valid reason to not learn something just because it's different than you used to? Is that a valid reason? I'm asking
Oh,
Magetta as well.
I gotta think.
That sounds dumb to me.
I don't have a strong feeling about it being wrong.
No, it's not wrong. You're not committing a crime. It's just bad. You're not doing anything wrong per se. Like again, you're not doing
No,
anything
if that
illegal.
is not wrong, then there's no way it's bad.
No, that's not the
It might
case.
be it might be an
It's not wrong to
inferior.
eat junk, and you can.
You might argue it's like a less optimal or suboptimal reason, but that's not doesn't mean it's bad like in general sense.
No, if I'm assuming that the purpose is to acquire better tools. I'm assuming that's a common sense. If that's not an assumption, then I agree. Then I'm not judging. If your goal is not to acquire better tools, then I don't know what you're doing. But it's not wrong. It's not bad.
Well,
And we are live discussing this, by the way. So take care.
Llamas, but take a look, man. Uh, that's all. And Magita can laugh at this, but it's relative. It's good for what? A better tool regarding what? Right? So it depends on what you want to achieve, depends on who you are, depends on a bunch of stuff.
No, but you don't know.
Yeah,
That's exactly the
think
problem, Nathan. You don't know if it's better to whatever your mission
I
is.
think his point is based on
You don't-
you have an ultimate reasoning behind having the act behind the act of learning. So
No.
that
That's
would be
no, but that's
getting
my
better.
case, Magetta. The case that I'm
Okay.
talking to Nathan here is not that. It is even more basic than that because Nathan is saying, oh, it depends on what your goal is. Yeah, but I don't care. It can be whatever. You don't know if the tool is better because you didn't try it.
Yeah, that's what I
It's
was going to say.
bad by nature.
Yeah, that's a bit of bullshit, Lemus. You don't have to try it or learn it to know that it's like, oh, I know. How can I say that?
No. But that's different than what we were talking about. You were talking
Yeah, I
about
agree
if you
that's
have a
different.
reason that you know, oh, I don't have to try it because I have a reason that it's
You are
already
saying
good
that
enough.
you cannot know if you don't try it, but that's bullshit.
No.
You don't
I'm
need
saying
to
that you don't
try
know if you
out.
don't try it if your reason is because it's different. Of course, it's because your reason is different. If I'm looking at the whole and I
But
know
take
it's
a look.
deep, I
If
don't
the
have to
reason
jump
is
into
because
it.
it's different, then of course you don't have to try it. Like if you know that it's different, and you don't have to try to know that it's different.
No, but okay, but think of the anecdote that I was talking about, right? So he's doing now functional programming, like he's doing F sharp. He's immersed in the immutable stuff and all of that.
No,
So like
but still.
yeah,
Go,
okay,
Maggie.
no, just let me finish. So like he's getting now like a bunch of the benefits that functional programming imprints on a language, but I think it started because it was a lightweight thing, and then like we started arguing, okay, like it's a dumb reason to drop the thing, which I sort agree. I don't fully agree because I gotta understand. Okay, that's the point where we are discussing. So what we're saying is people have different goals for different things, right? So that's what Nathan is saying by real.
Yeah, that's it
They,
what he's saying. But the problem that the thing that Anton is not getting is that I am exclusively talking about someone that is not choosing to not learn it just because it's different. It's not because you have a reason like it is different and this causes that and it is
okay,
not aligned with my goal. That's a different argument.
So take a look regarding because it's different. Let's suppose I want to be optimal in some way. Optimal in, I don't know, I want to be a god in this thing I'm already doing. Well, then I will not do something different.
yeah, that's
Yeah,
a valid reason as
if
well.
what you're doing involves necessarily the tool, like I want to be a great the best person that uses a hammer. If your goal is that, then
That's
okay.
an example. You don't need to do that point.
No, you do need because you need a goal
I
that
think
specifically
judge.
involves the tool.
I
No,
think
I'm
you should
saying
be
that
able.
one of you wanting to be a god in a specific tool and then that is the way you justify not doing anything different. That's one like example. I'm not saying that's always the justification for.
Yeah, but you will always have to require some argument of the sort. Like think of this, like you have a target, right? Everyone has. Let's suppose everyone has a different goal. Like I want to become I don't know, a monad master. Nathan wants to be a. He does like I don't know, a lambda calculus interpreter on the breakfast, something like this. So
Thing
you have.
is, would you guys say that not feeling like it is a reasonable or is a fair point of not wanting to do
That's my
something?
okay. That's my stance. I don't know because that should be directed towards the goal. If I don't know the goal and the goal is mine, I cannot judge. I might judge from my standpoint on seeing them as being suboptimal on achieving the goal they want. But
Yeah, I will be.
You cannot say if it's suboptimal if you don't know the goal, Magid.
I will confess that
that's
if
what I
your
say.
goal requires
Knowing
being
the
a master in
goal,
the tool, I
I
agree with
said,
Nathan.
I explicitly said knowing the goal.
Okay.
I think.
No, you
Saying to
said
somebody
that. You
watching.
you definitely
Okay.
said that. You definitely said that. Yeah. Anyway, it's already past 2 hours, so I'm gonna finish the thing.
Oh, why don't we go 7 again?
Oh, we will, but not recorded.